let's begin. So the first thing that we are going to talk about is homogeneous functions of two variables. First, we'll understand what does it mean in two variable case, then we will generalize it. Okay. So, all right, let's start. So let's see what is the definition for homogeneous function of two variables. So the function f of two variables, and these two variables are x and y, defined in a domain D, is said to be homogeneous. So homogeneous of degree k. So whenever we talk about homogeneous function, they are homogeneous of some degree. So a function is said, a function of two variables x and y in a domain D is said to be homogeneous of degree k if for all x comma y in the domain, if I am doing t times x and t times y, I have t times k and then f x comma y for all t greater than 0. So this is the definition of homogeneous function. So what is a homogeneous function? A function of two variables x and y, which is defined in the domain that we have, is called a homogeneous function of degree k. Agar, if for all the elements in the domain, if you let's say pick an element x comma y and you divide both the members x and y by t, then your function is such that it takes the form that you have t raised to the power k and then you have function f x comma y, and this is true for all t greater than 0, and this needs to be applicable for all the items in the domain. Okay, let's take an example and then try and see how do we what kind of functions are homogeneous. So as an example, let's say I have a function fx comma y, a x power a and y power b. Okay, so if I want to know if it is homogeneous or not, what is the first thing that I'm supposed to do? I'm supposed to take up an element x comma y. So I took up an element from its domain x comma y. फिर मैंने क्या किया? I divide both the elements by what? I multiply both the elements by what? T. So अब आपके पास फंक्शन वैल्यू जो निकालनी है वो आपको tx और ty पे निकालनी है, एंड उसके बाद आपको देखना है कि आपका फंक्शन क्या फॉर्म लेगा. ठीक है. So now if I put tx and ty in place of x and y, let's see what form does my function take. So I have to find ftx comma ty. So what will this be? Tell me.
ax raised to the power a.
So a tx raised to the power a, right?
Yes, ma'am.
Yes, and
ty raised to the power b.
Okay. So now let's simplify it more. So I can write it like t raised to the power a and x raised to the power a, right? And yes, similarly, I can write t raised to the power b and y raised to the power b. Okay. So now if you collect the items, if you collect t, we have t raised to the power a plus b, and then we have a, x raised to the power a and y raised to the power b, right? So this is my function. So now if you look clearly, what is this?
F of xy.
Yes, this is nothing but f of x comma y. And this is ta plus b. So हमारा definition क्या था कि कोई भी एक function आप लो f x comma y, and if you have a number t, if you multiply both x and y by t, and if you put it in your function should have a form like this, right? So your function should have a form like this. So does the current function that I've written has a form like this?
Yes, ma'am.
Right? So मेरा ये जो function जो हमने example लिया है, this is following the property, this is following the homogeneity property. तो मेरे function की degree क्या है homogeneity की? What is the degree of homogeneity?
A plus B.
Yes, degree of homogeneity is equal to A plus B, because whenever the degree is k, you have a power t raised to the power k. Okay. So all the functions such that this particular property is satisfied for all the points in the domain and for all t values, all the functions who satisfy such a property, they are called homogeneous function. And homogeneous of degree k would mean you have a power k here whenever you multiply by t. So you have a t power k in front of the function. Is it fine? Is this clear?
Yes, ma'am.
Okay, so
Yes,
now I want to ask you, I have a function 3x squared y minus y cube. Tell me if it is homogeneous or not, and if it is homogeneous, what is the degree of homogeneity? And then whosoever gives me the answer will have to tell me why whatever they have done is right.
yes, ma'am. Function is homogeneous and
Yeah.
degree of homogeneity is 3.
Okay, so function you are saying is homogeneous. ठीक है. And the degree is 3.
3 ones.
Okay, so what did you do? How did you check it?
I put f tx comma ty. So it's like thrice of tx t square x square into ty minus t cube by cube.
Okay.
So from here I took t cube as common,
Yes.
and then the rest of the function will be equal to fx comma y.
Okay. Lovely. Exactly. So we had, so what did we do? In place of x and y, we wanted to calculate what is the function value at tx and ty, and we simply replaced x with tx and y with ty, and then we started to see what is the function value. ठीक है? So उसके बाद हमने क्या किया? 3 t squared x squared ty minus t cube y cube. And then we had t cube 3x square y minus t cube y cube. And then if we bring t cube in front, we are left with 3x squared y minus y cube. So what is this? This is nothing but your function, right? So we just have this function value fx comma y and then t cube. So that means this function is homogeneous first thing. Why? Because this function has a form like this. And then what is the degree of homogeneity of this function? Whatever is the power here becomes the degree of homogeneity. Okay. All right. Is this fine?
Yes, ma'am.
Okay. So now let's see what are the different kinds of properties of homogeneous function. क्या क्या properties वो satisfy करते हैं when you do partial derivative, when you do double derivative, क्या क्या properties जो हैं एक typically आप एक homogeneous function में देखोगे. We will talk about that, and then we will take an example to verify if whatever properties we have written here, are they satisfied or not. Okay, so let us look at some properties. So properties of homogeneous function. So इसकी एप्लीकेशन आपको इकोनॉमिक्स में कहाँ आएगी? जब भी आप प्रोडक्शन फंक्शंस के बारे में बात करोगे. प्रोडक्शन फंक्शन क्या होता है कि इट इज द फंक्शनल रिलेशनशिप बिटवीन आप कितना इनपुट दे रहे हो एंड आपको कितना आउटपुट मिल रहा है. ठीक है. सो जब आप पढ़ोगे कांस्टेंट रिटर्न्स टू स्केल, इंक्रीजिंग रिटर्न्स टू स्केल, डिक्रीजिंग रिटर्न्स टू स्केल, तब आपको होमोजेनियस फंक्शन का कॉन्सेप्ट जो है वो यूज होगा. ओके. So let's first look at some of the properties of the homogeneous function. So the first property is, it is also called Euler's, some people say Euler's theorem, some people say Euler's theorem. So choose how would you like to pronounce it? I say Euler's theorem. Euler's theorem. It says that if f comma x comma y is homogeneous of degree k, then this should be satisfied. X times partial derivative of x plus y times partial derivative of y, that is equals to k times fx comma y. So this is the Euler's theorem. So whenever a function is homogeneous of degree k, this particular statement needs to be satisfied. What is this? X times partial derivative of x plus y times partial derivative of y should be equal to whatever is the degree of homogeneity times the function value. And this both sides means whenever this particular statement is satisfied for a function, that is a function of homogeneous of degree k. So it goes both way. जब भी एक function homogeneous of degree k होता है तो ये वाली statement satisfy होगी, and जब भी ये statement किसी function के लिए satisfy होती है, this also holds. So whenever this particular condition holds for a function, that function is homogeneous of degree k. So this holds both sides. Okay. So ये statement का मतलब होता है if and only if and only if. मतलब this moves in this direction also and this moves in this direction also. Okay. So that is one. Another property of a so now whatever property that we are going to discuss, they will be properties that are followed for a homogeneous function of degree k. So if fx comma y is homogeneous of degree k, then whatever holds I am writing there. So if function fx comma y is homogeneous of degree k, then first order partial derivatives, so with respect to x and with respect to y. So the first order partial derivatives, both of them, they are both homogeneous of degree k minus 1. So the degree of homogeneity gets reduced by 1. So अगर एक function fx comma y is homogeneous of degree k, तो उसके जो partial derivatives हैं with respect to x and with respect to y, they are both homogeneous of degree 1 lesser k minus 1. The next property that we have is if we have a function fx comma y, okay, and we know that this is homogeneous of degree k, so then this function value is equal to x power k f1 y by x, which is again equal to y raised to the power k f x divided by y comma 1, and this holds for x greater than 0 and y greater than 0. मतलब ये जो तीनों वैल्यूज जो हैं, this and this and this, they all are equivalent for a function of homogeneous, for a function which is homogeneous of degree k. अब आप सोचोगे कि okay, why is it true? For example, just deviating a bit, if this function is homogeneous of degree k, right, then what happens? F tx comma ty is equal to what? T raised to the power k f x comma y. Okay, so for a moment, let's say that t is what? T को आप क्या मान लो? 1 by x मान लो. Suppose t is equals to 1 by x, and then let's try and see what is the function value. So what is the function value now? If t is 1 by x, can you please rewrite this equation for me?
by x to power k f1 comma y by x.
So so t is 1 by x, matlab x by x comma y by x, right? And then 1 by x raised to the power k and f x comma y, right?
Yes, ma'am.
Then you can write x by x is 1. So you can say f1 comma y by x is equal to fx comma y x raised to the power k, right? And then if you simply multiply this side, what do you get? Fx comma y equals x raised to the power k f1 y by x, which is nothing but what is written here also. So what is written here also, right? This is what is written. Now, similarly, if you do a different transformation wherein you say that t is nothing but 1 by y, then you will get this result. Okay. So these are slight transformations that you have to do to find out what is the relationship here. So yes. Is this clear? How did we find out why these two are equal?
Yes, ma'am.
Okay. Okay. Anusha says yes. Okay. All right. So हमने दो प्रॉपर्टीज देखे. सो लाइक अभी तक हमने तीन प्रॉपर्टीज देखे. क्या क्या हो सकते हैं? वन इज यूलर्स थ्योरम. द सेकेंड वन इज अगर आपका फंक्शन होमोजेनियस ऑफ डिग्री के है, सो जो भी आप पार्शियल डेरिवेटिव्स करोगे both with respect to x and with respect to y, they will be homogeneous of degree k minus 1. And this third property, we said, okay, this can be written like this and also like this. So we saw different forms in which we can represent the function. There is one more property for homogeneous function that I would like to discuss here, which is, okay, so there is the fourth property here, that this is regarding double partial derivatives. So if you do x squared f double prime 1 1 x comma y plus 2 times x comma y f double prime 1 2 and then you do y squared f double prime x comma y. For a homogeneous function, it is going to be nothing but k times k minus 1 f x comma y. So it's like saying कि आप यहाँ पे अगर double derivative कर रहे हो, so then you will have two things here, one for the normal function and one for the partial derivative. And if you're doing it, just one partial derivative, it will be whatever is the degree of homogeneity. So that could be just way to remember it. So this means that if you do x square partial derivative, double derivative with respect to x, plus 2xy partial derivative, double derivative 1, 2, and then partial double derivative with respect to y times y square will give you nothing but k times k minus 1 fx comma y. So these are the four properties that we've talked about homogeneous function of degree k. Now let's try and see if, so we've just said, okay, they are true, but let's try and verify them once if they are applicable for a function that we see. So these are the four properties. Any doubts in understanding the properties, understanding the statements? Because now we'll move on to verify the properties. So first is regarding how you take the partial derivative, multiply by x, partial derivative multiply by y, that is nothing but k times the function value. Then whatever is the partial derivatives, they are also homogeneous of degree k minus 1. Then how you write these homogeneous functions. And then finally, this one property is going to be talking about the second order partial derivatives. Are we clear this till this point?
Yes, ma'am.
Okay. So let's try and verify each of the properties in detail for a function. Okay. So let's say, again, we are using the same function. So my function is fx comma y, 3x squared y minus y cubed. So in the previous, the previous question, I asked what is the degree of homogeneity. So we said degree of homogeneity is 3, and obviously, yes, it is a homogeneous function. So since it is a homogeneous function, it needs to satisfy all the four properties that we've discussed. So what was the first property? Someone please tell me. That if this function fx comma y is homogeneous of degree k, then what should happen? Which is the Euler's theorem as well. What does the Euler's theorem tell you? What should I write here?
Multiply del f by del x.
Yes.
Plus y del f by del y is equals to k.
Yes.
F of x comma y.
Okay. So now हमें क्या करना है? हमारे पास ये फंक्शन है. हमें ये फंक्शन के लिए पहले हम लोग पार्शियल डेरिवेटिव निकालेंगे दोनों के लिए. x से मल्टीप्लाई करेंगे, y से मल्टीप्लाई करेंगे और फिर देखेंगे कि ये k टाइम्स fx, y आ रहा है कि नहीं. ठीक है. So we have to verify this statement. So what is partial derivative of f with respect to x?
6xy.
6xy. Yes. That's all?
Yes, ma'am.
Okay. So I am assuming by now all of you know how to do partial derivative. So जिसके भी respect में हम लोग partial derivative कर रहे होते हैं, उसके अलावा जितने भी variables होते हैं, we keep all of them to be constant. Okay. All right. So what is the partial derivative with respect to y?
minus 3y square
minus 3y squared and
plus 3x square.
and plus 3x squared. Yes. Okay. Is this correct? Not, please check.
Correct, ma'am.
Okay. So अब हमें क्या करना है? हमें simply ये equation निकालनी है. So we have to find x times partial derivative with respect to x, which is what? 6xy plus y times partial derivative with respect to y. So which is 3x squared minus 3y squared, right? So what is this? Let's see what it is. So this is 6x squared y plus 3x squared y minus 3y cube, right?
Yes, ma'am.
So उसके बाद what do we get? 9x squared y minus 3y cube, right? So if I simply take 3 to be 3 common, what do I get? I have 3 times 3x squared y minus y cube, right?
Yes, ma'am.
And what is this? And what is this? 3x squared y minus y cube. This is my function value. So this is fx comma y times 3. This is equals to what? This is equals to x partial derivative with respect to x plus y partial derivative with respect to y, right? And what should we have here? K times fx comma y. And what is k in this case? What is my degree of homogeneity in this case? 3. So that is why I have a 3 here. Okay. So that means the Euler's theorem is satisfied. So are you convinced that this is indeed satisfied?
Yes, ma'am.
Okay. So now let's try and look at the other property, the second property. Okay. So what is the second property? Second property says that if fx comma y is homogeneous of degree k, then f prime with respect to x and f prime with respect to y they will be homogeneous of degree k minus 1 each. Okay. So I know what is f prime x and what is f prime y. So what is f prime x and what is f prime y? So I know this is f prime x and this is f prime y. So now if you have to tell me what is the degrees of freedom of this function, okay, you can write it like let's say this is gx comma y. So what is the degree of homogeneity of gx comma y? And you can say that this is hx comma y. So what is the degree of homogeneity of this function? hx comma y. So what is the degree of homogeneity for these two functions? 2. Are you convinced it is 2?
Yes, ma'am.
And what about this one?
I'm 2 only.
This is also 2. So do I need to do it, or is everybody convinced that the degree of homogeneity for these two is 2 only? So अगर हमें let's say gx, y function है हमारे पास, इसकी मुझे degree of homogeneity अगर check करनी है तो मैं कैसे करूंगी? This g function is given by gx, y. Degree of homogeneity check करने के लिए आप क्या करोगे? you take g tx comma ty equals to, you see what it is. So g tx ty, and then you see what the value comes out to be. So you have t squared 6xy. So you have t squared g x comma y. So whatever is the power that you see here, that is the degree of homogeneity. Okay. So
Yes,
so the partial derivatives that we've seen, so this one and this one, they are both homogeneous of degree k minus 1. So k was 3, so k minus 1 is 2. So we have seen that the degree of homogeneity is 2. Okay. So this is clear. And the third property that we have is fx comma y is equals to xk f1 y by x is equals to yk f x by y comma 1. So since for this particular function, what is my k? My k is 3. So k is 3. So I can see that this function fx comma y is nothing but 3x square y minus y cube, right? So it is saying that this should be equal to this one. This should be equal to this. So I will simply write x raised to the power 3, and then my function value is 3. In place of x, I need to write 1. Okay. And in place of y, I need to write y by x. Right. And then I have a negative y cube. And then in place of y, it should be yx raised to the power 3. Right. So
yes,
now,
ma'am.
so now if I try to solve it further, what do I get? Yx minus y cube divided by x cube. And then if I multiplied by x cube inside, what do I get? 3x squared y minus y cube, which is nothing but whatever is the function value here. Okay. And similar thing I can do with this part also. I can write that this should also be equal to what? Y raised to the power 3. And in place of x, I need to write x by y. So my function is 3x by y squared. Y is 1 minus, then I have y. So y is 1. So this is nothing but 3x squared divided by y squared minus 1 times y cube. So this is equals to 3x squared y minus y cube. So all these three values are the same. Yes?
Yes, ma'am.
And finally, it is for you to check whether this double derivative condition, which was what? X squared f double prime 1 1 f x comma y plus 2xy f double prime 1 2 x comma y plus y squared f double prime 2 comma 2 x comma y. This is indeed equals to k times k minus 1 f x comma y. Okay, this will also hold true, but please check for yourselves. That this is indeed true. All right. So is this fine?
Yes, ma'am.
So now, since we've talked about homogeneous functions in two variables, now it's time to extend this idea and talk about what would be a general homogeneous function. So now we need to talk about general homogeneous functions. Okay. So let me write what is the definition in general for a homogeneous function. So a function f of n variables. Now we are talking in n variables. Defined in a domain D, okay, is said to be homogeneous of degree k if what happens, we simply just extend the idea that if you multiply each of the variables by t, what happens? So if you multiply each of the variables with t, what do you get? You have a t power k, and then you have a function f x1, x2, up to xn. And this holds for all t greater than 0. Okay. So this particular definition or condition should satisfy for all the points in the domain, for all x1 up to xn. So आप कोई भी point domain से उठाओ, उसको किसी भी एक t variable t real number से multiply करो. The only condition is it should be greater than 0. Then this particular condition should satisfy. Okay. And ये जो k value है, ये यहाँ पे it's not necessary that this needs to be positive only. This can be 0, this can be positive, and this can be negative as well. Okay, so there is no restriction on the k. So there is no restriction on what value can k take. So it can take any value. Okay, so this is the general definition of a homogeneous function. So we've defined homogeneous function for n variables. Okay. So अब homogeneous function अगर define कर लिया, तो Euler's theorem जो है, वो general case के लिए क्या होगी, वो भी हम लोग एक बारी define कर देते हैं. So what is the Euler's theorem become what? That suppose you have a function f is a function of n variables with continuous partial derivatives in an open domain D. Open set, closed set क्या होता है वो हम लोग आगे पढ़ेंगे. So you don't need to worry about that right now. Open domain D such that if t is greater than 0 and if x1 up to xn is a point in the domain, that means t times x1 up to t times xn should also belongs to D. So what is the condition here? Suppose we have a function of n variables with continuous partial derivative in open domain, and domain किस तरीके की है कि अगर आपने एक point लिया और आपने एक real number लिया t which is greater than 0, आपने इन दोनों को multiply किया, so जो resultant number आया वो भी domain में ही होगा. So आपकी domain इस तरीके की होनी चाहिए. ठीक है कि ये t से मल्टीप्लाई करने के बाद जो भी नंबर है वो ऐसा होना चाहिए कि एटलीस्ट डोमेन में तो हो, क्योंकि फंक्शन वैल्यू सिर्फ डोमेन के मेंबर्स के लिए ही निकाली जा सकती है. ठीक है. सो ये सब तो टेक्निकल रिक्वायरमेंट्स हो गए. उसके बाद सो व्हाट इज द एक्चुअल थ्योरम? इट सेज देन,
excuse me ma'am,
yeah,
I'm like when if t is greater than 0, like if t is 2 or 3, and if we multiply it with the domain x1 to xn, then it will obviously be out of the domain.
why? सपोज मेरी हाँ चलो पहले आप कंप्लीट करो. हाँ,
I'm like if domain is 1 to 9, 1 to 9
Okay.
belongs to D.
डोमेन
And-
इज 1 to 9.
Yeah.
1 to 9 what?
I'm like x1 is equal to 1, x2 equals to 2. That's what I'm saying.
अच्छा, तो वो तो आपने एक पॉइंट ले लिया, ठीक है.
जी.
1 2 3 अप टू मान लो n की वैल्यू 9 है,
Yes, ma'am.
ये बोल रहे हो आप.
Yes, ma'am.
ओके, तो 1 2 3 अप टू 9 हो गया. चलो, ये एक पॉइंट हो गया डोमेन में, ठीक है.
जी, ma'am.
अब आप क्या बोल रहे हो कि t जो है 2 है, ठीक है.
Yeah.
सो जब हमने 2 से मल्टीप्लाई किया तो मेरे नंबर्स क्या हो गए? 2 4 अप टू 18, राइट?
Yes, ma'am.
यही ना. तो आप बोल रहे हो कि फिर ये डोमेन से बाहर चला जाएगा. इज इट व्हाट यू आर सेइंग?
Yes, ma'am.
ओके, सो युवराज, डोमेन जो है, डोमेन अगर मेरी रियल नंबर है, लाइक रियल स्पेस है, नॉट रियल नंबर एक्चुअली. इफ माय डोमेन इज r पावर n, मतलब a set of all the real numbers. So जो पहला वेरिएबल है x1 can take any real value, x2 can take any real value, x3 can take any real value, up to x9 can take any real values, ठीक है. So अगर मेरी जो डोमेन है वो है रियल इसको सेट भी नहीं बोलेंगे, रियल आप मान लो कि r raised to the power n, meaning r cross r cross r cross r up to 9 times इस स्पेस में है मेरी डोमेन, ठीक है. तो ये एक मेंबर होगा मेरी डोमेन में, कोई एक पॉइंट, ये मेरी डोमेन का एक पॉइंट है, क्योंकि 1 भी रियल नंबर है, 2 भी रियल नंबर है और 9 भी, अप टू 9 भी रियल नंबर है, ठीक है. फिर आपने क्या किया, आपने t को 2 माना, तो 2 से मल्टीप्लाई करके ये जो नंबर आया, ये भी तो मेरी इसी डोमेन में आएगा. तो ये जो बेसिकली हम डिफाइन कर रहे हैं, ये हम अज्यूम ही करके चल रहे हैं, मान के चल रहे हैं कि हमारी डोमेन ऐसी है कि आपने अगर अपनी डोमेन से एक, ओके ओके ओके, हाँ, सो हम लोग मान के ही चल रहे हैं कि कोई भी एक पॉइंट अगर आपने अपनी डोमेन से लिया, कोई एक आपने t वैल्यू ली, अगर उसको मल्टीप्लाई कराया, तो जो भी पॉइंट होना चाहिए वो भी डोमेन में होना चाहिए. तो आप ये बोल रहे हो कि आपकी डोमेन की प्रॉपर्टी ऐसी है, आपकी डोमेन शुड बी सच दैट दिस प्रॉपर्टी इज सेटिस्फाइड. क्योंकि आप क्या करते हो, आप अपने फंक्शन में क्या वैल्यूज डालते हो, tx1 tx2, तो वो फंक्शन तभी डिफाइंड होगा जब वो tx t2 अप टू t9 जो है वो आपकी डोमेन के अंदर ही होगा, क्योंकि फंक्शन तो सिर्फ एक डोमेन के अंदर ही डिफाइंड होता है, ठीक है. सो ये सारे कॉन्सेप्ट यूजुअली आप मास्टर्स में पढ़ते हो when you talk about real algebra and real analysis, कि कौन सी डोमेन है, क्या डोमेन है, ये सब आप, if any one of you is interested in reading more about this, so this is called real analysis. real analysis में हम लोग ये सारी चीजें काफी पढ़ते हैं. So अभी के लिए you just need to understand the statement, that's all. अभी आपको ज्यादा dig deep नहीं करना है. Okay, so ये statement देने के बाद अब so हमने क्या बोला है कि I have a function which has continuous partial derivatives in an open domain such that अगर ये मेंबर मेरे डोमेन में है तो ये वाला मेंबर भी मेरे डोमेन में होना चाहिए, मेरी डोमेन ऐसी होनी चाहिए. So in that case what happens, then f is homogeneous of degree k in the domain if and only if what happens, summation I equals 1 to n xi f prime I x1 up to xn, this is equals to k times function value x1 up to xn. मतलब सिंपली जो 2 वेरिएबल का केस था उसी को हमने एक्सटेंड कर दिया कि x की जो i है वो वैल्यू लेगा 1 to n, तो x1 टाइम्स f प्राइम x1 x2 टाइम्स f प्राइम x2, x3 टाइम्स f प्राइम x3 अप टू xn तक आप मल्टीप्लाई करके ऐड करते रहो एंड दैट विल बी इक्वल टू k टाइम्स योर फंक्शन वैल्यू. सो जो 2 वेरिएबल में हम लोग बोल रहे थे x टाइम्स partial derivative with respect to x plus y times partial derivative with respect to y. This is equals to k time f x comma y. Okay, so अब ये जो है हमने n वेरिएबल्स के लिए एक्सटेंड कर दिया कि ये क्या होगा x1 partial derivative with respect to x1 plus x2 partial derivative with respect to x2 up to जो भी xn partial derivative with respect to xn. This is equals to k times your function x1 up to xn. Okay, this was Euler's theorem for a general case. Okay, so अगर ये वाली कंडीशन सेटिस्फाई होती है तो हमारा फंक्शन डिग्री k का होमोजेनियस है, and if my function is homogeneous of degree k, then this condition should be satisfied. तो यहाँ पे again if and only if है, मतलब this statement goes both sides. So if this is true, then this is true, and if this is true, then this is true. It goes both sides. Okay? Is it fine?
Yes, ma'am.
Okay, so now tell me, I have a function v1, v2 up to vn. This is equals to a v1, a1, v2, a2 up to vn, an. What is the degree of homogeneity of this function? So tell me, what is the degree of homogeneity of this function?
a1 plus a2 plus dot 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 an.
Okay, so how did you find that?
I'm simply by putting f tv1 tv2 dot 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 tvn. And when we put the values, they we put the t to power a1 plus a2 plus a3 common, and then we get f v1 v2 vn.
Okay, lovely. So you're correct when you say that degree of homogeneity is nothing but a1 plus a2 plus up to an. Is everybody clear why this is the degree of homogeneity?
Excuse me, ma'am.
Mm-hmm.
I have a small doubt, like this function is a Cobb-Douglas function.
Yes, it's a Cobb-Douglas function. Yes.
So for Cobb-Douglas function, there should be a degree and also everything should be up in a product.
Yeah. कह सकते हैं आप. हाँ.
Okay, ma'am.
So Cobb-Douglas functions जो होते हैं, they are homogeneous. So Cobb-Douglas production functions भी देखोगे आप economics में, and फिर उसमें you will also talk about constant returns to scale, decreasing returns to scale, and increasing returns to scale. Suppose just deviating 2 minutes just for, let's say I have a function f k comma l. So this k is capital. Okay, and this L is labor. Okay, and this function gives you how much output you can produce. So this is a production function. Production function क्या करता है? It tells you when you put k units of capital and L units of labor, how much output can you produce in the economy? Okay, so suppose if your function can be written like a k raised to the power let's say a and L raised to the power b. Okay, this is your production function. So you can see that this is homogeneous, right? And what is the degree of homogeneity of this function?
A plus B.
A plus B, right? So आपका ये production function है जो homogeneous है, and degree of homogeneity is A plus B, ठीक है? So अगर A plus B की value 1 है, तो आप इस function को बोलते हो constant returns to scale. इसका मतलब क्या हुआ? अगर आपने चीजें स्केल की, अगर आपने कैपिटल और लेबर को स्केल किया, स्केल करने का मतलब है मान लो आपने कैपिटल और लेबर को डबल किया, तो क्या आपका आउटपुट डबल होगा? सो इफ योर A plus B is 1 and if you double your output, I mean if you double your capital and double your labor, तो क्या आउटपुट डबल होगा?
No, ma'am.
नहीं. ओके, लेट्स सी. सो लेट्स से पहले आप K और L यूनिट्स यूज कर रहे थे, अब आपने कैपिटल डबल कर दी और लेबर भी डबल कर दी. ठीक है, तो अब आपको ये बताना है कि यहाँ पे तो हम लोग कितना आउटपुट प्रोड्यूस कर रहे थे, इतना. अब हम लोग क्या कितना आउटपुट प्रोड्यूस करेंगे when we have 2K and 2L? So it will be A 2K power A and 2K power B, right? इतना आउटपुट हम लोग प्रोड्यूस करेंगे.
Yes, ma'am.
Yes, ma'am.
So what will this be? A K raised to the power A and oh sorry, this is L. So L raised to the power B. ठीक है, and we have 2 raised to the power A plus B. ठीक है, so this is simply my production function. ठीक है, so this is F K comma L. ठीक है, so अब अगर ये A plus B की वैल्यू 1 है, so A plus B is 1, that means अगर आप कैपिटल डबल लगा रहे हो और डबल लेबर लगा रहे हो तो आपका जो आउटपुट है वो भी 2 times F K comma L हो रहा है, राइट? मतलब आपका आउटपुट भी डबल हो गया, राइट?
मैम,
हाँ हाँ,
अगर सिर्फ कैपिटल 1 से इंक्रीज करें तो
वो फिर एक अलग सिचुएशन हो जाती है. बट जैसे जब भी हम होमोजेनियस डिस्कस करते हैं ना, होमोजेनाइटी, तो होमोजेनाइटी की डेफिनेशन में हम बोलते हैं कि दोनों चीजें डबल हो रही हैं. अगर हम सिर्फ कैपिटल को 1 से इंक्रीज करें तो फिर आपको पता चलेगा दैट इज योर मार्जिनल प्रोडक्ट ऑफ कैपिटल, कि अगर आप कैपिटल 1 यूनिट से बढ़ाओगे तो आपका जो आउटपुट है वो कितना यूनिट बढ़ेगा. दैट इज अ डिफरेंट कॉन्सेप्ट.
ओके मैम.
ओके, सो अगर आपका A plus B equals to 1 है, तो इसका मतलब क्या हुआ? अगर आप कैपिटल और लेबर दोनों को डबल करोगे तो आपका जो आउटपुट है वो भी डबल हो जाएगा, राइट? सो इस सिचुएशन को बोलेंगे कांस्टेंट रिटर्न्स टू स्केल. मतलब हुआ कि आपने जितना अमाउंट कैपिटल और लेबर को इंक्रीज किया उतना ही अमाउंट आपका आउटपुट जो है उसी मल्टीपल से इंक्रीज हो जाएगा. और अगर ये A plus B ग्रेटर देन 1 होता तो क्या होता कि अगर आप कैपिटल और लेबर डबल कर रहे हो तो आपका आउटपुट इज बिकमिंग मोर देन डबल, मतलब डबल से ज्यादा बढ़ रहा है. इसको बोलते हैं इंक्रीजिंग रिटर्न्स टू स्केल. आपने किया डबल, आपको आउटपुट मिला मोर देन डबल. एंड इफ A plus B is less than 1, that means you have decreasing returns to scale. So आप कैपिटल और लेबर को डबल कर रहे हो बट आपका जो आउटपुट है इट इज बिकमिंग लेस देन डबल. ओके, सो ये इधर सो दिस कॉन्सेप्ट विल बी यूज्ड हियर, होमोजेनाइटी का. इज दिस क्लियर?
यस मैम.
Yes, ma'am.
ओके.